Okay, today we're looking at two kinds of series. So a series is a little different than just a sequence. A sequence, you just have, again, a whole bunch of numbers in a row. That's a sequence. With a series, we're basically looking at the sums, the partial sums of sequences, and trying to see if the sum converges or diverges. So a series, we're really looking at the sum of a sequence. So basically that's what's going on here. So we're looking at geometric series and telescoping series. So a geometric series has something of the form a times r to the k. So an example of that might be like 5 1/2 to the k, that kind of thing. And trying to find the sum of that. So let's start down here. Let's say we just wanted the sum, we're using s sub n, of the first n terms. Turns out there's a formula for that. The nth sum, basically you're looking at the sum from k equals 0 to n minus 1 of the a r to the k. And the formula for that is a 1 minus r to the n over 1 minus r. I have a little 1 r to the n right there. So an example there would be, we want the sum from k equals 0 to 10 of 1/4 to the k. On this one, the a value is just 1. We didn't have anything out there, so it's just 1. And if you look at the formula for the nth sum, you have an n minus 1 there, and then you get an n in the formula. So right here, if we want the sum up to 10, we need an 11 in the formula. It's just one number higher. So this is 1 minus 1/4 to the 11th over 1 minus 1/4. I did that in the calculator, and I got 1.333. Now what if we want to do these sums out to infinity? Well, what you end up doing is just looking at the limit of this partial sum expression. And if you think about this in the limit, as long as r is a number whose absolute value is less than 1, then this is going to go to 0, and you just end up at 1 over 1 minus r times whatever a is. So the same problem, 1/4 to the k, if you sum that out to infinity, you just get 1 minus 1, or 1 over 1 minus 1/4, which is 1 over 3/4, which is 4/3, which you can see we were pretty close to. Oh, we're being video bombed by my dog. You can see him down there. 4/3, which we were really close to right up there. So here's another one. The sum k equals 4 to infinity of 1/5 to the k. Well, a little bit of a problem that we have on this is our infinite sum formula only works starting at 0. So there's a couple ways that we could get around that, but the easiest way is just to rewrite this a little bit. The fourth term is 1 over 625. So we could rewrite this as 1 over 625 times the sum of k0 to infinity of 1 over 5 to the k. Basically what I'm doing is rewriting this thing in the form a times r to the k, where the a is 1 over 625, and we leave this as 1/5 to the k. Right, and then that lets us rewrite this thing, find the sum of this, and then just multiply it by the 1 over 625. So that's 1 over 625 times 1 over 1 minus 1/5, right? 1 over 1 minus a, and that turns out to be 1 over 500. This also works if you have a negative power. You want to sum from 0 to infinity. Just 1 over 1 minus negative 9/10 is 1 over 1 plus 9/10. That's 1 over 19/10. That's 10/19. So geometric series sums are really pretty easy. We just have a formula that works for infinite sums. It's a pretty simple formula, just a over 1 minus r. We have a formula that works for partial sums. It's a times 1 minus r to the n over 1 minus r. Pretty straightforward formulas. Okay, the second kind of series we're going to look at are called telescoping series. And basically what happens on these series is that a lot of middle terms cancel out, and usually only the first and last term end up mattering. So here's an example of a telescoping series, 1 over k plus 1 minus 1 over k plus 2. And I just wrote down the first few terms of this so you can see what's happening. If you put in 1, you get 1/2 minus 1/3. If you put in 2, you get 1/3 minus 1/4. If you put in 3, you get 1/4 minus 1/5. And you can see every middle term out as far as you sum is going to cancel. So in the end, all that you're going to be left with is the very first term, 1/2, and the very last term, k plus 2. As you let k go to infinity, this k plus 2, this is going to go to 0, and the sum of this thing is just going to be 1/2. Okay? Let's look at another telescoping series. Square root k plus 1 minus square root k. Again, I'm just looking at the first few terms so I can see what's happening. If you put in 1 here, you get square root 2 minus square root 1. If I put in 2, I get square root 3 minus square root 2. If I put in 3, I get square root 4 minus square root 3. Again, this term doesn't cancel, but this one does, and this one does, and so on and so on and so on. But the one that's going to live is going to be the very last one of these that we have, which will be the square root of k plus 1, and this term, the 1. So as you go out to infinity, you're left with the square root of k plus 1 minus 1, the limit as k goes to infinity. Well, this term goes to infinity, so this limit diverges. So even though almost all the terms cancel out, the term that survives, as you can see, just keeps getting bigger every time. Right? The 4 survives, then that's going to cancel, the square root 5 survives, then that would cancel eventually square root 6 survives. But the thing that's surviving every time is getting bigger, and this is going to diverge. Whereas on this one up here, when we expanded it out, the 1/2 lived, but then what happened every time was the smaller term was surviving out of each thing. So 1/3 cancels. You're left with 1/4, then that cancels, you're down to 1/5, then that cancels, you're down to 1/6, and you get a sequence of surviving terms that go to 0. That's how we ended up with 1/2. Here we ended up with something that diverged. Okay, that's pretty much what I want you to be able to do out of this section, is deal with telescoping series, deal with the first few terms, finding the sum of a geometric series, the first few terms, and then finding the sum of an infinite geometric series. The other thing that we didn't do here was something that we talked about the other day in class. If your r is greater than or equal to 1, these series are going to diverge. So that's something we know. If I took like 5 times 2 to the k, I know that's going to blow up, right? So we didn't spend time on that here, but there's a reminder. Okay, thank you.